Master darks and bias frames are quickly becoming a thing of the past. The latest generation of cameras feature extremely low read noise and dark current. It may soon make sense to forget about light frame calibration and just purchase a latest generation cooled astrocam. Light frame calibration could reduce to only flat compensation, followed by stacking and digital development. Well, for those of us, like me, who don't have unlimited funds, we need to understand and use the full light frame calibration methodology. If you just watched the CMOS digital camera primer, I'm about to do a deep dive into what bias and dark frames are all about. And if you stay until the end, you'll see my dark current comparison of 4 cameras, including the ASI 2600 MC Pro. Bias and dark frames are taken with the aperture of the telescope or lens covered so that zero light can reach the imaging chip. Typically, both of these frames need to be taken with the same ISO or gain as your light frames. Astrocam users will also need to ensure that the camera temperature and offset are the same as your light frames. Bias frames are taken with the shortest possible exposure. Dark frames are typically taken with the same exposure as your light frames. I keep using the word typically because dark optimization does give you some freedom with respect to ISO or gain, exposure, and temperature. Because bias frames use an extremely short exposure time, these frames have no chance to build up any dark current. Many people will say that bias frames only contain read noise, which is true, but it's not why bias frames are needed for light frame calibration. The standard method for obtaining a measure of read noise is to mathematically subtract the pixel values in 2 bias frames. The standard deviation of this mathematical difference is equal to 1.414 times the camera read noise. You will need to know what the camera electronic gain, or E per ADU, is to convert this read noise value into units of electrons. It is believed that this read noise is inherent in every image taken with your camera. Now let's talk about master bias frames. A master bias frame is created by averaging lots of bias frames together. The main purpose of doing this is that it eliminates virtually all of the random noise in these bias frames. That's right, master bias frames by design contain little, if not zero, read noise. So it's more accurate to say that a master bias frame has nothing to do with read noise. What a master bias frame contains is the offset or bias for every pixel that corresponds to 0 light. For DSLRs, these offsets will all be very close to the black ADU value discussed in the CMOS digital camera primer video. The pixels are certainly not all the same value, but the relationship to each other is very consistent. A master bias frame is only needed when you wish to perform dark optimization or dark scaling. For astrocam users, a master bias frame is also useful for deciding what value for offset is required for any camera gain. For astrocams, master bias frames are also very consistent, but the actual pixel values change with offset and temperature. There is also a real risk that the values may be negative. Unfortunately, negative values are not allowed, resulting in these values being clamped at 0. If too many pixels are clamped at 0, then the master bias is useless.